So the benefit is actually that you can control whether you want to use the heat that the sun produced to heat up your building, or if you want to block it because it's already warm enough.
Welcome at the first episode of the Brightlands Material Center podcast series. I'm Astrid Verberne, Community Development Manager at Brightlands Camelot Campus. And it's an honor to host scientist Daniel Mann today in our studio. Welcome, Daniel.
Thank you, Astrid. Happy to be here.
You're a scientist at Brightlands Material Center, and your department or your program you're working in right now is called Sustainable Buildings. Can you tell us what type of products you are developing there right now?
Yeah, definitely. So in our department, Sustainable Buildings, we work on the development of new materials to reduce the energy consumption in buildings. And here we mainly focus on the transparent part of the building skin, so windows and building integrated photovoltaics.
Why is that such a hot topic or cold topic, you could say so?
So you see that the built environment contributes to about 1/3 of the energy consumption in Europe. And especially with climate change and depletion of fossil fuels, we really need to reduce our energy consumption and also reduce the emission of CO2. And this is what we're working on.
So it's 1/3?
Yes, it's 1/3.
Normally you hear about cars and cows, but now it's windows, it's glazing and buildings.
Yeah, buildings, definitely. They consume a lot of energy.
Okay. And one of your current developments is a smart windows. I gave already some sneak preview on that one, but can you tell me a bit more about why it's called a smart window?
So this smart window, it's an energy efficient window, and it's adaptive to the environment. So it can change its properties from heat reflective to heat transmissive, depending on external stimulus.
Aha, okay. So they really react on the weather outside and they make sure that people inside the building are comfortable.
Yes, that's correct. That's correct. So it's that depending on the outside temperature, you either can let in your solar heat into your building to heat up the building when it's cold, or you can block it when it's too warm so that you have increased comfort and you reduce your cooling costs.
And how does it work? On what level? Is it on the molecules, or how does this switching work exactly?
So this works on a certain material. It's called a thermochromic material, which is coated on the window. And this thermochromic material can switch its or can change its crystal structure depending on the temperature. So at a certain temperature, the crystal structure changes, and then also the optical properties changes. And this then leads to the final properties that at cold temperatures, solar heat is transmitted into your building, and in hot temperatures, it's blocked.
Sounds amazing, really. When you're a scientist and you get a breakthrough like that, I can imagine that it's not coming easy. Can you share some full bits or tips and tricks for the listeners during the process of it's a real invention, is it? And can you share us some tips what you learned during this process?
So such a development obviously is always a long-term development, and it's also not a development only of one person, but of a whole team. So what we generally do at Brightlands Material Center TNO is we take interesting research from the universities, and then we develop it further so that it comes closer to market, where then companies can pick it up and make products out of it. And there are obviously many different challenges and pitfalls come with it, which you cannot always predict.
So it's what you do is it's really fundamental research. You make it suitable for society then.
Yeah, that's right. That's right. So we are looking at really applied developments to develop real products which have a benefit for society.
You're making a difference there. So
we hope so.
Let's get back to your materials part of it. What's exactly the benefit of these adaptive properties?
So the benefit is actually that you can control whether you want to use the heat that the sun produced to heat up your building, or if you want to block it because it's already warm enough.
Of course. So as a consumer, you can choose what you want and what you think is comfortable.
Yeah. So for the consumer does not actively choose, because the switch in properties is automatically. So the consumer doesn't have to do anything for it, but it's predefined in the design stage, depending on the building, but maybe also depending on the region, at which temperature this switch occurs. And this can all be predicted in the beginning. So at what temperature you need to switch your properties so that you can the optimum reduction in cooling and heating cost over the year. And for the consumer, what you have, so you have an increased comfort level and you have, a lower energy bill.
Okay, so you studied as well the behavior of people and when they are comfortable or what kind of temperature and when it's time for the coating to switch to another state of mind.
Yeah, so we are more focusing on the energy part, not so much on the comfort part. There are also other institutes and other groups who are focusing on comfort part, where we are also in contact with, since this is also a very important topic. Mm-hmm. But our focus mainly is the energy part and the energy reduction. Yeah.
Okay, that's clear, Daniel. Is this invention, is it really different to regular, already on the market, energy efficient glazings?
Yeah, there's a big difference. So when you look at what's already on the market, you see that the energy efficient glazing, which you can buy now, is all static. So that means that it blocks the solar heat the whole year. Okay. So that's obviously nice when it's warm outside and when it's summer where you want to block it. But in winter, this is really detrimental, because in winter, you want to have the sun and the heat of the sun in your building to help heat it up so that you don't need to use your radiator so much.
So that's, okay, the conclusion is it's really smart then.
Yeah, that's why we call it smart.
Okay. If you like this podcast series of the Brightlands Materials Center, please subscribe now to our new series and don't miss any of it. Thank you. Aren't there options to also reduce the heating demand?
Yeah, there indeed are. So this is mainly based on increasing the insulation of the window. So you can think about in very old buildings, you still have single glazing, so just one glass pane. Then now in buildings, you mostly have double glazing, so two glass panes with a air gap in between. You can further increase the insulation by going to triple glazing, where you have 3 glass panes and 2 air gaps. Mm-hmm. Or what you can also do, you can add a so-called low E coating to one of your glass panes in the double glazing, which then also increases the insulation and reduces the heating demand.
Mm-hmm. So you say then that the current energy efficient glazing is mainly optimized for either hot or cold regions then as well?
Yes, that's right. So, as I said, you can have heat reflective properties, which is good for very hot climates. You can have increased insulation, which is very good in cold climates. You also can have a window which combines both, but then still you have the negative effect of the solar heat blocking in winter. And you cannot reduce the heating demand as much as it would be possible. Mm-hmm. And there actually is the difference to our smart window.
Yeah, now I understand. You explained it very clear to me. So, for example, my private home, it's in the Netherlands, or maybe this studio here, it's really relevant too. We're summertime and it's extremely hot in here. So, would you advise such a smart window here too?
Yeah, definitely. So that's actually the part of region where we designed, or where the smart window is designed for. So regions like the Netherlands, like Germany, like Belgium, or other regions in Europe or all over the world, where you have, we call it an intermediate region, where you have hot summer and a cold winter. And in all these regions, the smart window performs best of all energy efficient glazing.
So where you have really seasons.
Yeah.
And there is relevance. Okay.
That's right.
You said that the optical properties of a smart window change at a certain temperature. can I see that as well happening in the product or in the coating? For example, by increased shadings of the glass, or is it not visible?
No, you don't see anything. So if you install this window in your building, you don't have to do anything for the switch. It happens automatically. You don't see it because the switch only happens in the part of the solar spectrum which is not visible and only contributes to heating. So yeah, if you have this window, you just install it and you enjoy the benefit.
It's really amazing that you can just put a coating on something and it changes, but it's invisible for the eye. It's really, it sounds like an amazing product. Can we go out and start shopping, Daniel, together? We go to a market and let's buy such a coating for my home.
Yeah, that would be amazing. So I would love to also have this kind of window already in my home. But unfortunately, that's not possible yet. So it's still under development. Currently, we can reproducibly produce high-quality coated glass on lab scale. So this is 10 by 10 square centimeter.
It's still very small, huh?
Yeah, it's still very small, yeah. And we are, at the moment, we are scaling it up to half meter by half meter.
That's going into the size of a window already a bit.
Yeah, that's right. And then in the next 2 years, we also plan to produce full-sized windows.
Okay, so I have to be patient a bit then.
Yes, a little bit.
And then are you involved as well with market introduction of these smart windows, or how does that work?
No, that's not something which we are doing as an institute, because we are only a research institute, so we're not selling any products. So the development then has to be picked up by a company who is then making a product out of it. So what we as a research institute are doing, we are co-developing products with companies, which then ultimately will take full control of the development in the final stage and introduce also this smart window to the market.
But there must be a lot of interest of brand owners maybe in the market. Is there already a company which is co-developing or partnering in your program?
So yeah, obviously we get a lot of interest, and it's definitely an interesting development for a lot of people. And we are also already working with several companies in bilateral projects and in larger consortia.
That's a good thing to hear, yeah.
Yeah, but for now, there's no exclusivity on the smart window yet. So there's still the possibility for companies to jump in, co-develop with us. Mm-hmm. So interesting parties can contact our business developer, Eugène Verkamp. Mm-hmm. And we're always looking for new partners and new projects.
It sounds like a really good opportunity for. Do you have? Which company would you love to get in touch with, or to maybe develop it further together with their experts? Or?
So obviously for Windows, you're always looking at big glass companies like Saint-Gobain, AGC, Pilkington, Guardian, something like this. So this would be the big fish.
Okay. Like I hope they listen. And so Daniel, we have talked a lot today about your new development, your program, the Brightlands Materials Center, your job. Can you, and before we wrap it up, this first episode, can you tell us a bit more how your day looks like working in a lab? You work in a lab, I assume?
So myself, I don't work in the lab anymore. So I'm a chemist. I studied chemistry. I worked a lot in the lab during my study, during my PhD, during my postdoc. Mm-hmm. But now at Brightlands Materials Center as a scientist, I'm mainly involved in project management, project acquisition, also doing a bit publicity, and everything related so that the team can work and can function. Yeah, but we have very dedicated people in the labs who are very skilled, and we're very happy to have them.
They must be glad with such a supportive person outside the lab who know how it works. Yeah, what they are doing. Okay, it sounds really interesting. Nice to have met you today. In our next podcast, I hope you like to continue talking about your. I heard you just published a study. You investigated exactly. I want to hear everything about it and the results and the insights. You even found more there. True, you just published a new report.
Yeah, that's right. So we just published a building energy simulation study where we looked at energy consumption of a residential building in many different climate regions. And what we wanted to do there, actually, we wanted to analyze the benefit of the smart window, depending on the climate, if you're in a hot climate, a cold climate, intermediate climate. But what we also wanted to do, we wanted to compare it to commercially available energy efficient glazing systems.
Of course, yeah.
That's what we did. Yeah.
Now, let's talk further then in the second episode, okay?
Yeah, I'm happy about it. Thanks for having me. It was really a pleasure. And I'm already looking forward to the next section.
That's a promise. Okay, see you next time. Thank you, listener. This was the first episode. And looking forward to hearing you back maybe on our next episode. Ciao.